Welcome back. Problem 6-24. So statement is express the shear and moment in term of x and then draw shear and moment diagram for the simply supported beam. So you can see this is beam AB that is simply support at point A. There is a support and at point B there is a support. From point A till the length of 3 meter, you can see this load is linearly increasing load, and then from this point it is going to decrease, and this load is 300 Newton per meter. So what we have to find is the shear and moment in term of x, and then draw the shear force and bending moment diagram. So let's start with the solution. The first step is that if we remove the support at point A, so definitely you will have a reaction force that is represented as, let this is AY, and similarly if you remove the support at point B, so there will be a reaction force By. So we will find this Ay and By by using the equilibrium condition. Now you can see that from this load is a linearly increasing load till this point. So this is a triangular. So if we convert this into a point load, so it will be like this, and this will be 1 over 2 into 300 multiplied by its length 3, and it will be acting at a distance of 3 by 3, which is 1 meter. So and here you can see the same load. So if you convert it into a point load, so it will be 300 multiplied by 1.5 into 1 by 2, and this will be acting at a distance of 1.5 divided by 3. Clear? So we will do that. I will just convert this into point load, and this will be equal to 1 over 2 into 300, and its length will be 3, and this will be acting at a distance of this total length divided by 3, which is 1 meter. Clear? And same if you convert this load, so there will be a point load, so 1 over 2 into 300 multiplied by its length, which is 1.5, and this will be acting at a distance of 1.5 divided by 3, which will be equal to 1.5. If I divide it 1.5, let me calculate. 1.5 divided by 3 will be 0.5, so it will be 0.5 meter. Now you can apply the equilibrium condition. The first equilibrium condition is that sum of all moment about point A is equal to 0, and taking the counterclockwise movement as positive. So about point A, the first force which is producing movement is By, and perpendicular distance is this, which is 4.5. So I will write By into perpendicular distance is 4.5, and it is producing counterclockwise movement, so it will be positive. The second movement which is produced by this force, which is 1 over 2 into 300 into 1.5, and it will be, the perpendicular distance will be this one, which is 3.5. 3 plus 0.5 is 3.5, and it is producing clockwise movement, so it will be negative. So minus 1 over 2 into 300 into 1.5, and perpendicular distance will be equal to 3.5. The other moment that is produced due to this load, so this load is this one, and perpendicular distance is this remaining, which is 3 minus 1 is 2 meter. So I will write it minus 1 over 2 into 300 multiply by 3 multiply by 2. Their sum must be equal to 0. So when you calculate and simplify all this, so you will get By will be equal to 375 Newton. So this is By. Okay, now we will find Ay by using another equilibrium condition. And what is that equilibrium condition? Is that sum of all forces along y direction must be equal to 0, and taking the upward force as positive. So you can see one force is AY, the second one is this BY, the third one is this force, and the fourth one is this one. So these two are negative because they are downward, and while BY and AY is upward. So AY plus BY, which is 375, minus this force, which is 1 over 2, 300 into 3, minus 1 over 2 into 300 into 1.5. So when you calculate it, you will get AY is equal to 300 Newton. So in our first step, we have calculated this AY and BY. Now we will find the shear and moment in term of X. So what we will do that is, you can cut this beam. I will choose another color. You can cut this beam over X is greater than or equal to 0 and less or equal to 3 till this. Clear? And when you cut it, you have to draw the shear force and bending. You have to draw this diagram. So this is AY, which is 300, and total this distance is X, and there is a triangular load. That is, what will be the magnitude up till this? So this will be equal to 300 into X by 3, because this is acting, this distance is X, so it will be 300 into X over 3, because it is acting on X of total length 3. Clear? And when you cut it, there will be a shear force V, and there will be a moment M. Let this is 0.1. So what if you convert this load into point load? So definitely you will, what we will do, it will be equal to 1 over 2 into 300, and this 300, when this will cut with, it will be equal to 100x. So it is equal to 100x. Let me choose smaller one. So 1 over 2 into 100 multiply by x. Clear? And it will be acting at a distance of this x by 3. So this distance will be x by 3. Now we will apply equilibrium. We will find this V and moment. So first equation is that sum of all forces along y direction must be equal to 0, and taking the upward force is positive. So one force which is 300, that is upward. So 300 minus V minus this 1 over 2 into 100x. Their sum must be equal to 0. So from here you will get V is equal to 300 minus 50x. Okay. So this is 100x into, okay, so this is 100 and this is total x. So I forget to multiply x over here. So this is 100x square. Okay, so this is 50x square as well. So this is the equation of shear force for x is greater than 0 and less or equal to 3. So this is your equation number 1, and its unit will be in Newton. Now we will apply second equilibrium condition, that sum of all moment about 0.1 is equal to 0, and taking the counterclockwise moment as positive. So first moment is 300 into perpendicular distance is 3. The second moment is this force, and perpendicular distance is this x by 3, and third moment is m. So their sum must be equal to 0. So I will write m is counterclockwise plus, due to this force moment will be 1 over 2 into 100 x square, and it will be acting at a distance of x by 3, minus 300 into perpendicular distance is x. So their sum must be equal to 0. So from here, when you simplify it, you will get moment is equal to 300 x minus 50 divided by 3 x cube. And the unit will be in Newton into meter. So this is the moment equation for x is greater than 0 and less or equal to 3. Now, what if I cut this beam? I will choose another color. Let's choose yellow. So let if you cut the beam over here. So let this is your total x. Now you can see we will choose another so that it can be visible. So this is your x. Now you can see that x is greater than or equal to 3 and less or equal to 4.5 meter. So the remaining this portion will be, I will draw this. So total is this is x, total is 4.5. So this will be 4.5 minus x. Total length of the beam is 4.5, and if you remove this x, so it will be, so I will basically redraw this below. So let's draw this. So if I draw that beam again, so there is a shear force, there is a cut, so there will be a shear force V, and there will be a moment at this end. This is the point B where we have By is equal to 375, clear, and there is a triangular load. Okay, so this distance was 4.5 minus x, 4.5 minus x, and this load will be now it was 300. Okay, this was 300, so it will be 1 over 2 into 300 into 4.5 minus x, clear, 1 over 2 into 304.x, and that will be acting at a distance of 4, this distance, and this distance I will write over here. This will be 4.5 minus x divided by 3. Okay, so basically you will have this, let me check it again, this 300, 1 over 2 into 300 into x, 1 over 3, 4.5, and the distance will be, again this will be 4, there is 4.5 minus x, because this load is, if I represent this load, so here I will write it, this will be 300 into 4.5x over 300 into 4.5x over the length, which is 1.5 meter. So 1.5 meter. So I have, you have to make sure that this is 1.5, clear. So basically this will give you, if I calculate it, so in short, this 300 divided by 1.5 will give you this will be equal to 200 into 4.5 minus x, 200 into 4.5 minus x. So if I represent it like this, so again here this term, this whole term, if you simplify it, it will be equal to 200, 1 over 2, this term 300, this is 200 into 4.5 minus x into 4.5 minus x. Okay, now it's clear. All this term is equal to this. Now apply equilibrium condition that sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So you can see one force is this one, the second one is this one, and third one is this one. Their sum must be equal to 0. So V is upward. So V minus this force, which is minus 1 over 2 into 200 into 4.5 minus x into 4.5 minus x plus by, which is 375. Their sum must be equal to 0. So when you simplify it, you will get V is equal to 100 times 4.5 minus x square minus 375, and the unit will be in Newton. So this is your equation number 3. Now we will apply sum of all moment about, let this point 2 is equal to 0 and taking the counterclockwise movement as positive. So you have one movement is this one, which is clockwise. The second movement is by into perpendicular distance is 4.5 minus x. The third one is this force multiplied by this perpendicular distance, which is this one. Their sum must be equal to 0. So 375 into perpendicular distance 4.5 minus x minus 1 over 2 into 200 into 4.5 minus x into 4.5 minus x, and perpendicular distance is 4.5 minus x divided by 3, and there is a external movement clockwise. Their sum must be equal to 0. So when you solve this, you will get the movement will be equal to 375 point into 4.5 minus x minus 100 over 3 into 4.5 minus x whole cube, and the unit will be in Newton into meter. Let this is equation number 4. So equation 3 and 4 are valid for x is greater or equal to 3 and less or equal to 4.5 meter. Now we have all this equation 1, 2, this equation 3 and 4. They are shear force and bending moment in term of x. So we will move and draw the shear force and bending moment diagram. For that I have to copy this figure and I will paste it downward on new page. Paste. So let me paste it like this, and we will copy the equations as well. So how I will copy? So definitely here you have to copy these two equations so that we can easily draw the shear force and bending moment diagram. You can resize them. Okay, and then we will move toward equation number 3. I will paste it over here, and the last one is equation number 4. Okay. So for bending moment diagram, what I will do is that I will draw a vertical line from each side of the beam, of the length of this beam. Clear? and there will be a horizontal line. So first we will draw the shear force, and shear force will be in Newton. This is your 0 point. Okay, so if you put x is equal to 0 in equation 1, so definitely you will get v is equal to 300 Newton. So at this, let each division is 100, so this is 300 Newton. So this will be your first point. Now at x is equal to let at x is equal to 3. So if you put in equation number 1, you will get v is equal to minus 150. You can check it, you can put it 150 minus 150. So 3 point is somewhere here. Clear? So this is 100, this is 150, so 150 will be this point. Now you can check that this shear force is second degree curve. So this shear force will be a second degree equation, but we do not know. So we will find the place where the shear force will be 0, because you can see that in between these 2 points shear force will be 0. So if you put v is equal to 0, and that is equal to 300 minus 50x square, so from here you will get x is equal to under root 6 meter. And this under root 6 meter is actually, if you use calculator and find this under root 6, so under root 6 will be equal to 2.4445 meter. So at a distance of 2.54 meter, so this is 3, so let this point is somewhere here. Clear? This is x, let this point is 2.45 meter. So at this point it will be 0. So your shear force from shear force diagram will be like this one. And it better is if you can easily put each and every value of x, so you will get a better shear force diagram. So it will be like this. It will be like this, but then you have to this. Okay, now for x is greater than, for x is equal to 4.5 meter, put in equation number 3. So when you put x is equal to 4.5, so you will get v is equal to minus 375. So this is 200, 300, so 375 will be somewhat here. And this is also a second degree curve, and this will be go down to this point. So this is minus 375 Newton. And this was your this is your shear force diagram. Now we will draw the bending moment diagram. So again I will choose the red color. Now for x is equal to 0, put it in equation 2. So when you put it in equation number 2, so definitely you can see for x is equal to 0, so a moment will be equal to 0. So this will be 0, and this will be moment will be in Newton into meter. For x is equal to 2.45, where shear force is 0. So when you put x is equal to 2.45 in equation number 2, so you will get the maximum bending moment, that is 440 Newton into meter. So let each division is 100 Newton meter. So 2, 3 and 440 will be somewhat over here. And at x is equal to 3 meter, so you have to put it in equation 2, so you will get moment is equal to 4, so sorry, this is 490, not 440. So I will correct it. So this will be somewhere here. This is 490. And when you put x is equal to 3 meter in equation number 2, so definitely you will get moment is 450 Newton into meter. So at a length of 4, this is 1 2 3 100 2 3 4, so 450 will be here at the mid. This is 440. Now at x is equal to 4.5 meter, so you have to put it in equation number 4. So when you put equation number 4, x is equal to 4.5, so you can see if you put 4.5, so this term will be 0 and this term, so whole term, so we will get moment is equal to 0. So it will come at x is equal to 4 point, moment will be 0. So now we will join them. You can see the moment will be third degree, so it will be like this, and then it will be smoothly coming to this, and then smoothly coming to not a straight line. You have to correct it. This is not a straight line. This should not be a straight line, so you have to, it will be like this one. So you can see that this is a length of 2.45 meter. This is a length of 3 meter, and total length is 4.5 meter. So this is the bending moment diagram. This is the shear force diagram, and this is the bending moment diagram. I hope you have enjoyed this video. Again, if you have any question, you can ask me in comment section. Also, those who are new to my channel, then subscribe it and keep watching. Thank you.